Everyone is afraid of unsafe Rust, but there are certain cases when going unsafe in Rust is more than suitable, and today we'll go through each of those cases. The video will be split into several categories, from generally safe to jacked. Please, if I help you, support me by subscribing, liking the video, and leaving a comment. And donations are greatly appreciated too. What is unsafe? Well, Rust is a safe language, but certain things are allowed to be done still in Rust, but you need to use unsafe and be careful. First of all, remember that using unsafe isn't a crime per se, because sometimes using unsafe will make things easier, more readable, and even faster. After all, if using unsafe was really that bad, Rust wouldn't have this feature. However, it could lead to tougher debugging, undefined behavior, and other sorts of problems. Rust has a way to call code from other languages. Here is an example of how you can call ABS from the C standard library. Unless there is a problem in the C function itself, this should not cause any issues. Don't ask me why, but in Rust you can create a variable which is both static and mutable at the same time. To change it, you need to use unsafe, and that's basically it. Keep in mind you also need to use unsafe when just reading the variable. So let's say we have a union and we want to pattern match on it. Let's create an instance and pattern match like shown. As you can notice, I'm using unsafe. Even if we didn't have to pattern match, we'd still need to use unsafe to read it. As we know, unwrap simply gets the value out of sum if the option is definitely not none. Well, if we do unwrap a none, Rust gives us a readable error which says that we can't do it. So let's pretend we're 100% sure we will never have any issues here. Then we can use unwrap unchecked. This isn't in the generally safe category because issues with options are quite common, and many other methods that have unchecked at the end may require us to use unsafe. Not all Rust intrinsics want us to use unsafe, but most do. Let's for example take a look at transmute. According to the docs, transmute reinterprets the bits of a value of one type as another type. If you're a Rust developer, you already feel the unsafe sounding connotation. Here is an example program which turns do into second. The enum is implicitly defined like so. Quite useful if our goal is to go through each of the possible values of an enum. So we define n as a technical value, loop until it, and turn every I into an enum component. Well, we could use another intrinsic instead of n. It's called variant count. Exactly the same, but we use unsafe. Is it better? Up to you. There's also stuff like assume, which informs the compiler that a condition is always true and leads to undefined behavior if it is false, and stuff like size off. If you want to go deeper into it, you can realistically just drop your whole program into unsafe and write C with Rust syntax, or just write C instead, because this isn't Rust anymore. Raw pointers are unchecked by the borrow rules of Rust, so we need to use unsafe to dereference them. Now close your eyes if you're a safe code activist. As I said before, you could realistically write C with Rust syntax if you like it so much, but I hope you're a good person. Well, literally everything you can do requires unsafe. If you write code like this, I'd also recommend you to use no std then. Inline assembly for low-level operations can be used with unsafe. Please don't do it if you respect the borrow checker even remotely. Here is an example of adding 10 to 5. As you may have noticed, use cases for unsafe vary from fairly safe to not even writing Rust anymore. I'd personally recommend you to never go above the could cause issues category. Have a good time learning Rust.